Hello there, this is Mr. Sutton bringing you a lesson on circles in the coordinate plane. In this one, we're going to figure out how to write equations of circles and to graph circles. For the real-life application here, we're going to determine whether a space lab will cross a certain point in outer space. To get things rolling, let's say we have 2 points on a graph, x, h and h, k. There's a certain distance between these 2 points, like any 2 points. The distance formula tells us the distance between 2 points is the square root of x2 minus x1 squared plus y2 minus y1 squared. Basically, Pythagorean theorem in two-dimensional space. If we take all the points a certain distance from a fixed point, h, k, we get, look at that, a circle. And the distance between those 2 points becomes the radius. So we could rewrite this distance formula as square root of x minus h squared plus y minus k squared, and that all equals the radius here. The circle formula, you basically just get rid of the square root by squaring both sides, so we have all the stuff inside the square root equaling r squared. H, k is our center in this setup, and then r, whatever's being squared over here, turns out to be our radius. So that's our little intro on circles. Given this information, pause the video and see if you can write an equation of the circle described below with a center of -4, 0 and a radius of radical 7. All right, let's see how you did. Now, all you had to do was plug these numbers into the circle formula. So we had x minus -4, or x plus 4 squared. We had y minus 0 squared, or just y squared. And then radical 7 squared is just plain old 7. We're going to get a little more practice with circles and do a real-life application while we're at it. Major Tom's spacecraft is running low on fuel. He's stranded at a point shown below, right here, 3, -13 we'll call this, and a space lab is orbiting on a circle with the center and the radius shown. So here's the space lab, here is the circle, ooh, isn't that fancy, and here's the radius of that circle, 7. Based on this, will Major Tom be rescued? Now, it kind of looks like he's on that circle that space lab's orbiting on. But we're in space, right? I mean, maybe this is like 500,000 miles. I mean, who even knows? So it'd be nice to know if he's exactly on that circle and is going to be rescued. How can we figure out if a point is on a circle? Well, first we need the equation of a circle. So pause the video and find the equation of a circle with these properties. All right, let's see how you did. So we'll have x minus 5 squared and y plus 6 squared equals 7 squared, 49. Now, how do we know if a point's actually on this circle? Well, we just have to plug the point in for x and y. And if it comes out true on both sides, the same on both sides, we know we're on the circle. So plugging that in, we can write 3 minus 5 squared and -13 plus 6 squared. So this is going to be 4 plus, let's see, this is 49. Definitely doesn't add up to 49. So unfortunately, Major Tom is not going to be rescued. That's a huge drag. Somebody should write a song about it. So at this point, we're pretty good at figuring out the equation of a circle if we know the center and the radius. However, what if we don't know the radius? What if we have the center and one other point that the circle passes through? So we're going to start this off like all our problems, where we write the standard circle equation here. But now, instead of just plugging in -3 for h and 7 for k, we're trying to figure out what r squared is. We could do that if we also plugged in an x and a y value here on the left. Doing that would give us all constants on the left side, and whatever all this stuff evaluated to, that would end up being r squared. So that's what we're going to do. We're going to plug in the center and whatever point they gave us to figure out r squared. So we've got the point 2, and then we're subtracting a -3, so this will be 2 plus 3. And then we've got the point -5 minus 7, so that's going to be our y minus k. This is going to be 5 squared plus -12 squared, or 25 plus 144, which adds up to 169. So that's r squared. You don't have to square root this to find the radius because the radius isn't what we care about. We just care about radius squared. So now that you've found r squared, plug that in with the center that you already had, and you'll get your final equation. So that'll be x plus 3 squared plus y minus 7 squared equals the r squared value of 169. For our last problem, we are going to graph a circle if we're given the equation. So in order to graph a circle, you need to know two things, the center and the radius. Using just those two items, you can graph the whole thing. So let's first find our center. This will be -2, 1. So that's somewhere over here, right there. Next, figure out the radius. So that's going to be the square root of whatever this number is, because this is really r squared they're giving us. So the square root of 9 gives us 3. And then once you find that radius, plot 4 dots, whatever the radius is, that distance away, in each of the 4 major directions, up, right, down, and left. So we've got 3 up, 3 to the right, 3 down, and 3 left. I mean, technically, you're 3 away in every single direction, even the in-betweener sort of directions, but I'm not sure how far 3 is going diagonally. So I'll just go with what I know. Finally, just connect the dots and draw that circle. So there we go. For this last example, we'll go over how to write something in center radius form, or the standard form of a circle. This form that it's in right now is called general form, and it's not really all that helpful for much. So for center radius form, you essentially have to get it with some squared parentheses, which means you have to complete the square for both of the variables. And as you're doing this, just make sure that everything you add on the left side, you also add to the right side. So as a first step to doing this, let's move that 4 over to the right side, so -4 on the right, and we'll also put the x's with the x and the y with the y here. So I've rewritten this, so I've got x squared minus 4x and y squared plus 6y equals -4. Now I'm going to leave a little space between the x's and the y's, and in that space I'm going to add my numbers in that are going to complete the square for each variable. So for the x's, taking half of the x term, we've got -2. I'm going to square that, add that over here on the left, and I'm also going to make sure I add it over on the right. And for the y's, half of 6 is going to be 3. Let's square that and add that to both sides. And now I have to go ahead and factor, or turn these into squared parentheses for the x's and the y's. So for the x's, I've got x minus 2 squared. For y, this is going to be y plus 3 squared. And over on the right side, we've got -4 plus 4 plus 9, which is going to simplify to just 9 when those 4's cancel. So now I've got this in center radius form. My center then is going to be +2, -3, and my radius will be the square root of 9, which is 3. So that's it for this one. Till next time, this is Mr. Sutton signing off.